Hi everyone, I am Jayachandran, Assistant Professor in Mechanical Department from Manur Arasar JJ College of Engineering, Nattala. Now I am teaching about the subject Process Planning and Cost Estimation. Here I am taking Unit 4, Production Cost Estimation. This unit includes the main contents. First one is forging shop, second one is welding shop, third one is foundry shop, and final is types of jobs and cost components. The table of contents in this chapter includes introduction to cost estimation, types of jobs in production, components of production cost, forging shop estimation, welding shop estimation, foundry shop estimation, and final one is comparative analysis and summary. Coming to the introduction to production cost estimation, the definition of cost estimation is the process of forecasting the expenditure required to manufacture a product considering all direct and indirect costs is the main definition of cost estimation. And the importance of cost estimation is it enables pricing decisions, budget planning, profit analysis, competitive bidding, and ensures financial viability of production. The objectives include determine selling price, control cost, evaluate alternatives, plan production schedules, and assess profitability of orders. And the scope include covers material cost, labor cost, overhead charges, tooling cost, setup cost, and profit margins across all shop operations. The classification of production cost include first one is direct cost. Direct cost includes raw materials, purchased parts directly traceable to product. And the second one is direct labor cost. Direct labor cost means wages of workers directly involved in manufacturing. And the prime cost is the direct material plus direct labor cost combined. That means prime cost. The factory overhead means direct or indirect cost, which means power, tools, supervision, depreciation, etc. And the selling overhead means marketing, distribution, and administrative expenses. The total cost means prime cost plus factory overhead plus administration overhead plus selling overhead. All the total costs are included in the to find out the total cost. That means total cost is equal to prime cost plus factory overhead plus administrative overhead plus selling overhead. Also, these formulas are used in problems to find out the total cost, also to find out the above mentioned different types of costs in the production cost. That means direct material cost, direct labor cost, prime cost, factory overhead, and selling overhead. Coming to the next session, types of jobs in production. The types of jobs in production includes mainly 4 different production. That means first one is job production, second one is batch production, third one is mass production, the fourth one is continuous production. Job production means single or small quantity of unique items made to customer order. For job production, high skill, flexible setup, high unit cost are needed. For example, the job production for the example is special machine parts, dies, jigs, etc. are the example for job production. And the second one is batch production. Batch production means groups of similar items produced together. Setup cost spread across batch, medium skill level required. In this production, the medium skill level is very much required for the batch production. I already told, groups of similar items produced together is called as batch production. Simply we can say groups of similar items produced together. For example, gear sets, valve bodies, castings, etc. are the example for batch production. And the mass production means large quantities of standardized products. We can know the name also indicates mass production. That means large quantities of products are produced or manufactured. Dedicated equipment, low unit cost and high capital investment are very much important in the mass production. Example, bolt, nuts, pistons, connecting rods. These all are included in automobile field or automobile production. That means large quantities of products are needed to develop an automobile production parts. That means all the production parts are involved in the automobile for this example. So these are the examples included in the mass production. Very large quantities are produced by the different ways of products, standardized products. The final one is continuous production. Continuous production means that non-stop flow process for high demand products. That means automated lines, very low unit cost, high throughput. So the continuous production means that, I once again repeat, non-stop flow process. That means continuous. So it is not discontinued, it is continued non-stop for the high demand products. Customer needs demand products in the day-to-day life. For this, a continuous production is needed to produce the demanded products with the non-stop flow process. That is called as continuous production. Simply we can say that is known as continuous production. Example, steel billets, castings, extrusions, etc. These are the main important examples for continuous production. This is the cost sheet structure. This is very important one to understand the cost sheet of different materials to find out the amount or cost of different types of cost we can find out. So we can see that the direct material cost, DMC, it can find out through raw materials plus bought out components. The second one is direct labor cost, DLC, is equal to basic wages plus DA plus PF plus ESI. Prime cost is the DMC plus DLC. By the above equation, we can find out prime cost. That means simply we can say prime cost PC is equal to DMC plus DLC. DMC means direct material cost, DLC means direct labor cost. And the third one is factory overhead, FO. Percentage of DLC or machine hour rate is the factory overhead. The factory cost FC is equal to PC plus FO. PC means prime cost plus FO means factory overhead cost. From the above equations, we can find out also the factory cost. The fourth one is administration overhead. Percentage on factory cost. We can find out by percentage on factory cost is equal to administration overhead. The cost of production is equal to FC plus AO. FC means factory cost, AO means administration overhead. The selling overhead is the percentage on cost of production. So we can find out total cost per cost of sales is equal to COP. That means cost of production plus selling overhead. And finally, the profit is calculated based on percentage on total cost or selling price. Once again I read, profit is equal to percentage on total cost or selling price. So we can calculate total profit also, and final is the selling price of the product. We can find out the total cost plus profit is the selling price of the required product, or the selling the product of different products in the market. The one product or each product has each way of selling price according to the above different cost sheet structure. That means cost sheet structure includes all the different types of costs, such as direct material cost, direct labor cost, factory overhead, administration overhead, selling overhead, and profit. These are all included in the cost sheet structure to find out the selling price of the product. So hence we can say that selling price is equal to total cost plus profit. Machine hour rate is the next session of this unit. Machine hour rate is simply, we can say that machine hour rate is equal to total annual machine overhead cost divided by annual machine hours. So we can find out machine hour rate is equal to total annual machine overhead cost divided by annual machine hours. In this machine hour rate, we can say that, or we can understood the different ways to find out the machine hour rate. The first one is depreciation. Machine cost per useful life in hours is a depreciation, and the repairs and maintenance include percentage of machine cost per year. Space charges means floor area into rate per square meter per hours. The interest on capital means capital into rate per annual hours. Power consumed means kilowatt rating into hours into tariff rate is calculated by power consumed. Consumable means oil, coolant, minor tools per hour, etc. also are included in the consumables. Hence we can say that to find out the machine hour rate, all are included in the machine hour rate. Next topic is forging shop. Forging is the oldest of the mechanical working, that is metal forming arts, having its origin with the primitive blacksmith at metal age times. Forging is also defined as the process in which the desired shape and size of an object is obtained through the plastic deformation of the metal of the object. It is performed by hammering or pressing the workpiece that is to be brought into a specific shape and size. So the forging involves shaping heated metal using compressive forces. Cost estimation in a forging shop must account for the energy intensive heating processes, die cost, press operation and skilled labor involved in hot and cold forging operations. That means based on the temperature at which forging is carried out, forging can be classified as the above said hot and cold forging operations. So the types of forging includes hot forging, cold forging. Hot forging means when the forging is performed on the metal above the recrystallization temperature, it is called hot forging. Simply we can say when the forging is performed on the metal above the recrystallization temperature, it is called as hot forging. Examples: engine components like connecting rod, crankshaft, camshaft, etc. are produced by hot forging. Cold forging means when the forging is performed on the metal below the recrystallization temperature, it is called cold forging. Once again I read: when the forging is performed on the metal below the recrystallization temperature, it is called cold forging. Examples include components like bolt heads, nails, rivets, etc. are produced by cold forging. So hammer forging includes drop steam power. Press forging includes hydraulic and mechanicals are included in the press forging type. Roll forging and upset forging are also done by the forging process, and the closed die and open die forging are also we can do due to forging type. Also forging processes include hand or smith forging, drop forging, press forging. Also we can say that the forging operations, that means forgings produced by a blacksmith, are the result of a sequence of standard operations. These operations include upsetting. First one is upsetting. Upsetting is the process of increasing the thickness or the cross-sectional area of the workpiece by reducing its length. Only the part to be upset is heated to the forging temperature and the workpiece is struck at the end between hammer and anvil. Therefore, to achieve the upsetting, force is applied in a direction parallel to the length axis. So the forging operations include: first one is the upsetting process, the second one is drawing down or fullering process, the second one is drawing down or fullering process. The drawing down is a process of increasing the length of a bar and reducing its thickness or width. For this purpose, the force is to be applied in a direction perpendicular to the length axis. So setting down is the third process. First one is upsetting, second one is drawing down or fullering process, third one is setting down process. Setting down process is an operation which usually follows drawing down. This operation can be performed with a hammer and a flatter. This is the main difference between the drawing down and setting down process. This method is used for smoothing of a square or rectangle article. This method is mostly used for the smoothing of a square or rectangle article. The fourth one is bending. Bending also included in the forging operations. The fourth main operation, bending. Bending is the process by which a metal rod or pipe can be bent to form various shapes without damaging its internal gain structure. Bent shapes such as angles, ovals, circles, etc. can be done by forging. It is carried out by hammering the workpiece, which is kept on the edge of the anvil face or horn. The circular bends are made by using the beak of the anvil. So bending is the operation by which a metal rod or pipe can be bent to form various shapes without damaging its internal gain structure. So the fifth one is punching. Punching is the process of producing holes in a workpiece. Simply we can say that punching means also familiar to punching. It's a process of producing holes. That means punching in the workpiece. It is done by placing the workpiece over the hole in the anvil or a cylindrical die to the required size or over a hole of correct size in a swage block. Coming to the sixth process in forging process, that is drifting. Drifting means after a hole is punched, it may be opened out to any size and shape by driving a tapered drift through it. That means drifting. This operation is known as drifting. Simply we can say this is called drifting process. The final process of the forging process is swagging. Swagging is the process of removing the irregularities on the surface of the workpiece produced by the process of drawing down. Two swage blocks, upper swage and bottom swage, are used for swagging operation. The bottom swage is held in anvil. The hot workpiece is held in between the top and bottom swages. Hammer blows are given over the top swage. So we can say that the forging processes includes 7 different types of operations. The first one is upsetting, second one is drawing down or fullering, third one is setting down process, fourth one is bending process, fifth one is punching process, sixth one is drifting process, and the seventh one is swagging process. Also, the estimation of material losses in forging are shear loss, tongue hold loss, scale loss, and the flash loss and sprue loss. These are the losses included in the estimation of material losses in the forging process. So we can find out the losses by using different formulas, like to find out the value of losses included in the workpiece material, to find out the losses included in the forging operations, such as shear loss, tongue hold loss, scale loss, as I already told, the flash loss, sprue loss, etc. Mainly 5 losses are included in the forging process, estimation of material losses in forging. In forging shop, cost components are billet or raw material cost, die cost, press or hammer cost, heating cost, labor cost, overhead and profit. So the weight of billet into rate per kg includes scrap allowance, that is 5 to 15% and flash allowance. Is the billet or raw material cost. Die cost include die cost per number of forgings per die life. Die life varies 5,000 to 50,000 pieces depending on material. And the press or hammer cost is the machine hour rate, MHR, into time per piece, TPP. So MHR includes depreciation, maintenance, power, etc. The heating cost is a fuel That means gas or oil consumption per heat into fuel rate. Typically 0.5 to 1.5 kg fuel per kg of forging. Labor cost include time per forging into labor cost or labor rate. Includes hammerman, heater, press operator, trimmer or includes in the labor cost. The overhead and profit includes factory overhead on labor, that is 60 to 150%, administration overhead, selling overhead and profit percentage on the total cost. These are the forging shop cost components. The forging shop estimation formula and example are given below. So we can find total forging cost per piece is equal to material cost plus heating cost. Material cost plus heating cost plus die cost plus labor cost plus MHR cost plus MHR means material overhead. We already know the MHR cost in the previous section. MHR cost plus overhead cost. A worked example is taking a automobile product, connecting rod forging, that has the different billet weight, heating cost, die cost, labor cost, plus MHR, factory overhead, administration overhead, plus selling overhead. Finally find out the profit. I already told the different equations we already studied in the previous session. For this, different cost equations are needed to find out the various cost included in the forging shop. So we can find out due to the different equations to find out the value of the connecting rod manufacturing process. Okay, coming to the next topic, welding shop. Welding shop estimation involves calculating expenses for joining metal parts by fusion or pressure. Costs depend on type of welding, electrode or filler consumption, power, pre and post weld operations and joint preparation. So different welding processes are included in the welding shop, such as SMAW. SMAW means shielded metal arc welding, also called stick welding. The second one is MIG or MAG. MIG means metal inert gas. MAG means metal active gas welding. Both are equal type of welding process. The third one is TIG welding. TIG means tungsten inert gas welding. It is shortly we called as TIG welding. Mostly used welding process called tungsten inert gas welding. The fourth one is SAW welding. That means submerged arc welding. Okay. The next one is OAW. That means oxyacetylene welding. Once again, OAW means oxyacetylene welding, also called gas welding. We can say that it is also known as gas welding also. The final one is RSW. That means resistance spot welding. RSW means resistance spot welding. These are the main important welding types included in the welding shop, used in the different means of metals to join by the different temperature ratios and the joining of the metal joints together. These are the main important types of welding processes or welding types. The welding shop components, that means welding shop cost components, are electrode or filler cost and power cost, labor cost, overhead and consumables. Also, all the shop like foundry shop, welding shop, such as forging shop, and different types of production cost estimations are included in this unit. So we can find out all the power cost, labor cost, overhead, and different types of costs are included in the different cost estimation processes. So we can find out electrode cost per kg into consumption is electrode or filler cost. It means consumption is equal to weld metal deposited or deposition efficiency. That means SMAW, shielded metal arc welding, also called stick welding. We previously studied this type of welding. That means SMAW is equal to 65% and MIG includes 92% approximately, and include flux cost for SAW process. SAW means submerged arc welding process. In the power cost, power is equal to welding current into arc voltage into arc time divided by 1000 into power factor. This is the equation to find out power in the power cost in the welding shop processes. Multiplied by power tariff, that means the required amount divided by kilowatt per hour. That gives the power cost. That means the power cost we can find out. And also we can find out include ideal running and equipment losses are included in the power cost. And also labor cost, coming to the labor cost can be found out through the equation or the process by which it is to find out the operator wages plus helpers. These are included in the labor cost. That means the operator wages plus helpers are included in the labor cost. Only operator and helpers are included in the labor cost. So the time is calculated easy in the labor cost is time is equal to arc time divided by operator factor. Operator factor also within the range of 0.2 to 0.5, and add setup, fit up, cleaning time. These are also included in the labor cost. Labors are adding that setup for the particular manufacturing process, fitting up the machines and required tools to manufacture that product, and cleaning time. Also maintenance is also required. So the cleaning time is also involved in the labor cost process. Final one is overhead and consumables. The overhead and consumable includes shielding gas cost. That means MIG or TIG. MIG means metal inert gas or metal active gas welding, and TIG means tungsten inert gas welding. Also overhead and consumables includes wire brush, chipping hammer, PPE, etc. Machine depreciation and MHR, material handling cost are also included in the this type of overhead and consumables. Also overhead percentage on DLC, direct labor cost plus profit margin, is the total profit margin cost. We can find out. Welding shop, the key formulas or basic equations used in the welding shop are weld metal volume V, that is capital V, is equal to cross sectional area of weld into length of weld. Weld metal mass W is equal to V into density of metal, that is 7.85 gram per cc for sheet steel. Electrode consumption is equal to weld metal mass divided by deposition efficiency, that is DE. Arc time is equal to electrode consumption divided by deposition rate, that is kg per hour, and that is the unit of deposition rate. Welding time is equal to arc time divided by operator efficiency factor, that is OEF, operator efficiency factor. Power, kilowatt hour, that is the unit of power, kilowatt hour in terms of kilowatt hour, is equal to I into V into arc time divided by 1000 into PF into eta. Eta means efficiency. So I is the current, V is the voltage. Arc time is the labor or the worker take the time to weld. So we can find out the equation. Power is equal to I into V into arc time divided by 1000 into PF into eta. And the final total cost is equal to material plus power plus labor plus electrode plus overhead plus profit. All the cost are, all the above mentioned cost are added together. We can find out the total cost of the product in the welding shop. So once again I read, total cost is the total expense included in the material, power, labor, electrode, overhead and the profit. All are included in the total cost or are calculated. And so we can find out the total cost of the material. This is the worked example for MIG welding, that means metal inert gas welding or metal or active gas welding. Given 500 mm butt weld on 10 mm mild steel plate, I is equal to, that means current I is equal to 200 amps, V is equal to 24 volt, DEC is equal to 92%, OEF is equal to 0.35, power is equal to, power means 8 rupees 8 power consumption, that means rupees 8 per kilowatt hour. So we can find out weld metal volume A is equal to 600 mm square, L is equal to 500 mm. So we can find V is equal to 60 into 500, that means 30,000 mm cube. So weld metal mass W is equal to 30,000 into 7.85 into 10 raised to minus 3. So G is equal to 235.5 gram, that is converted to 0.2355 kilogram. Electrode wire needed, W per D is equal to 0.2355 divided by 0.92 is equal to 0.256 kg at rupees 320 per kg is equal to 81.9, that is 81 rupees 9 paisa. Arc time is 0.256, already we calculated the electrode wire, that is arc time kg per 3.0 kg per hour depreciation rate, that is a depreciation rate is equal to 0.085 hour. Welding time, arc time divided by OEF, arc time divided by OEF, that means 0.085 divided by 0.35 is equal to 0.244 hour. Also we can calculate power consumed 200 into 24 into 0.085 divided by 1000 into 0.8 is equal to 0.51 kilowatt hour. At the rate heat is equal to 4.08. Labor cost also we can find out the formula by substituting. We can got the answer 0.244 hour at 60 per hour, that is 14.64. Shielding gas 15 liter per minute into 5.1 minute into 0.08 is equal to 6.12. That is the shielding cost. And the factory overhead means 100% DLC 14.64, and the profit is 15%. That means 15% on total is equal to 18.20. That means rupees 18.20 paisa. The foundry shop also include cost estimation. The cost estimation of foundry shop includes: a foundry produces metal castings by pouring molten metal into molds. Cost estimation must cover charge preparation, melting, pattern, mold making, core making, fettling, and heat treatment. So the foundry shop also includes the material cost, labor cost, direct expenses, overhead expenses, etc. Also the material cost include two types of different cost. That means that includes direct material cost and indirect material cost. The material cost is the two components of material cost are direct material cost and indirect material cost. So direct material cost is the net weight of casting. So volume of material required for casting into density of material is the calculation, first step to find out or to calculate the net weight of the casting. The second one is the process scrap, that is weight of runners, gates, risers, etc. consumed as a part of process in getting casting. This is generally taken as 15 to 20% of the net weight of the casting. So the casting load includes sand casting, die casting, investment casting, centrifugal casting, etc. Sand casting most commonly used casting is the sand casting. Green sand, dry sand, or shell mold are included in sand casting. We can use the sand casting. Die casting means permanent metal molds, high accuracy and high output we can get through the die casting. Investment casting means lost wax process, complex shape, tight tolerances are included in the investment casting. Centrifugal casting includes rotating mold, ideal for cylindrical parts. Here the foundry shop charge calculations are I already told in the welding shop. Also we can say that charge is equal to materials to be melted together to obtain desired composition of molten metal is the charge calculation in the foundry shop. We can see that the charge material, percentage, weight, rate, cost are included in the table. We can find out the total charge by adding the percentage, weight, and the cost of the different means of charge material. So net metal yield is equal to 95%. That means 5% melting loss added to 20 to 25% of gates, risers, and flash. That means recirculated means of value. Also are calculated also by means of adding together in the material charge material by means of percentage, weight, and cost. Coming to the foundry shop, molding and core cost, pattern cost, molding cost, core making cost are included. So the different means of amounts are given below, given in the pattern cost, molding cost, and core making cost. So we can find out the value by means of the different formulas used in the foundry shop. Foundry shop full cost build-up. So we can find out the metal charge cost, melting cost, pattern amortization, molding cost, core making cost, fettling and cleaning, heat treatment if required, inspection and rejection, factory plus admin overhead, administration overhead. These are the different means of full cost build-up. So we can find out the profit also by using formula percentage on total cost, usually 10 to 20%. So these are the different equations or processes included in the foundry shop. Also a worked example, CA flywheel is the worked example. We can see the cost sheet. Given CA flywheel, net weight 25 kg, casting yield 70%, pattern cost 15,000 per 1000 castings. So we can find out the different values by using the equations present in the foundry shop. Finally, we can find out the selling price. We already studied the study in the welding and the first means of foundry shop and the welding shop. We can find out the total selling price, that is approximately 2380 per casting. All are calculated by using the formulas included in the each components or casting costing the different materials. The overhead absorption methods are: first one is on direct labor cost, on prime cost, machine hour rate, labor hour rate. That means overhead rate is equal to total overhead divided by total DLC, direct labor cost, into 100. Symbol used when labor is dominant cost, common in foundry and forging shops. Easy to calculate. And the percentage on prime cost is equal to overhead rate is equal to total overhead divided by total prime cost into 100. That means balanced approach. The third one is machine hour rate, MHR, annual machine overhead divided by annual machine hours. Best for capital intensive shops used in welding base, CNC, press shops, etc. Most accurate for machines. Labor hour rate is the final one. LHR is equal to total hour overhead divided by total labor hours. That means accurate for labor shops, appropriate for labor intensive operations with varied wage rates. The comparative analysis for all the three shops are given below. That means primary process, key material cost, main energy form, overhead basis, dominant cost factor, typical overhead percentage, rejection rate, skill level required, best suited for. These are the three main shops. That means forging shop, welding shop, foundry shop. All the forging, welding and foundry shop have the different means of comparative analysis based on the processes and the equations used. So we can see that the compressive deformation, billet plus die cost, thermal furnace, that means machine hour rate, heating plus die, 100 to 200 on DLC, 2 to 5% rejection rate, skill level required, high hammerman, best suited for high strength parts. All have the different means of parameter. We can find out the different values and different processes included in the forging, welding and foundry shop. So the factors affecting cost estimation accuracy are the material price fluctuation, machine utilization rate, batch size effect, labor efficiency, scrap and rejection rate, overhead recovery. These are the main factors affecting cost estimation accuracy. The modern cost estimation techniques are parametric estimation, activity-based costing, Monte Carlo simulation, analogous or historical, future-based costing, ERP or MES integration. These are the modern cost estimation techniques to find out the technical values of the different means of production. Key takeaways are: cost estimation is essential, overhead must be correctly absorbed, update rates regularly checked, shop specific factors dominate, batch size and yield are critical, digitize and automate. These are the key takeaways for the process planning and the estimating the cost of different manufacturing processes. Here the unit is over. Thank you.